All right, we're into lesson number 3. It's Wednesday's work. Now, this lesson is designed to follow on from the first 2 lessons, which looked at square numbers and triangular numbers. And today, what we'll discover is that there is actually a relationship between those two, between square and triangular numbers. So, we very much investigated the patterns that were involved, and today we're going to look at what that relationship is as revealed by the patterns. So let's get started. Let's review what we've done. I want you to jot down very quickly what is a square number. And question 2 is actually very important because it comes into our assessment. In the assessment, you are asked to prove whether a number is square or not, or whether a number is triangular or not. Basically, you need to be able to discuss the properties of that number to prove or disprove it. So I would like you to do that one as well. Jot down what the first 5 square numbers are and then draw the 5 square numbers as dot patterns or arrays. All right, pause the video now and complete the first 4 questions. All right, let's see how you went. What is a square number? Well, a square number is the product of a number multiplied by itself. A square number can form a square-shaped array. So if you wanted to talk about 9, you could say 9 is a square number because it is a product of 3 multiplied by 3. Or you could draw 9 in that square-shaped array. 1, 2, 3, 4, 5, 6, 7, 8, 9 dots. All right, how can we prove it? Well, I think I just discussed that. But if it's a square, the number will be able to form a square array or be a product of a number multiplied by itself. The first 5 square numbers are 1, 4, 9, 16 and 25. And they look like this. You can see 1, 4, 9, 16 and 25. 5, lots of 5 is 25. All right, let's move on. We revised what's a square number. Let's do the same for a triangular number. So there are 4 questions here for you to answer. Pause the video, have a go at these, and come back and check how you went. Pause now. We're back. Let's see what you did. Did you say something like this? A triangular number is a number that creates a triangular shaped array. How do we prove it? Again, I'm going to reinforce. This is important because this comes into your assessments. Make sure that you can justify in a written explanation. Something like this. A triangular number creates a triangular shape, and each row should grow by 1. And we'll see that down here in a moment. The first 5 triangular numbers are 1, 3, 6, 10 and 15, 1, 3, 6, 10, 15. In this particular right angle representation or right angle array, you can see each new row is longer, 1 longer than the previous row. Or if you go vertically, you can see 1 followed by 1, 2, 1, 1, 2, 1, 2, 3, 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, and so on. Now, we said before that square and rectangular numbers are related. Let's investigate how. First of all, let's put all of our square and rectangular numbers on this grid. So you choose 2 different colors. You have this sheet of paper, so you can mark your square numbers and then mark your triangular numbers using 2 different colors. And then answer those questions. Are there more square or triangular numbers between 1 and 100? And why do you think there are more of one than the other? So pause the video for a couple of minutes while you complete this task. Okay, let's have a look how you went. There are 11 square numbers between 1 and 100 and 13 triangular numbers. There are the triangular numbers. There are the square numbers. Notice that 2 of them overlap. One is both triangular and square, and 36 is both triangular and square. There will be others larger than 100, I think. Maybe that's something you can investigate, but definitely there are 2 under 100. And why do you think that? You might have said something like, I think there are more triangular numbers because the pattern grows by an additional row. However, square numbers grow by multiplying numbers by themselves. Now, when we know that multiplying numbers, they do grow much, much larger than just adding numbers. And that's probably a very good reason why there are more triangular than square. All right, we're going to open a learning object in a moment, and it looks something like this. So if you've got the learning object yourself, you can open it shortly, but I'm going to open it up and demonstrate in the video, and I'm going to create 16 on a Geo board. And in making 16, I then want to make 2 triangles inside the square so that they don't overlap. All right, let's see how I can go about that. This is what the Geo board looks like. Okay, so I'm going to start with this band here, and I'm going to attach it to that peg, and 1, 2, 3, 4, finish it off on that peg. Then I can drag it across, 1, 2, 3, 4, and drag it up, 1, 2, 3, 4. So there is my 16 in a square. All right, now I'm going to choose a new rubber band, and the task for me was to create that 16 as 2 triangles. There's one triangle. Now I'm going to choose another triangle. I'll start it there, but I think I'll change its color to green. So I'll drag it across, and then I'll drag it down. Now what you will notice is all of the pegs have been accounted for. This one here is inside the boundary of this, so we say it's counted. Now 16, and then there are 16 here. 2 smaller triangles can make that square. And this is the pattern we're talking about. There is a relationship between the triangles and the square, because this represents a square number, this represents triangular numbers. Now if I count 1, 2, 3, 4, 5, 6, that is 6. And here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 6 there, 10 there, 16, which happened to be the number here. All right, I'll just go back to our PowerPoint. So we did complete that task there, and this is what we got. We had our square, 4 lots of 4, 16. Then we had the 6 in the smaller triangle, the 10 in the larger triangle to make our 16. And here's what we found. A square number equals 2 triangular numbers added together. And that is true for all of them. Every square number can be found by adding 2 triangular numbers. Now if I jump back up here, it says it's actually 2 consecutive triangular numbers. So if you remember earlier, we said 1, 3, 6, 10. Now I didn't add 1 and 10, or 6 and 15. I have to add 2 consecutive ones. So 1, 3, 6, 10. 6 and 10 are consecutive, and 6 and 10 make 16, and that rule holds true. So we had to compare the two. We found that two triangles fit into the square, but one is smaller than the other. All right, now it says to open the learning object again, and this time make a square with 25 pegs. And you are to create two triangles within this square. The triangle shouldn't overlap, same as we did before. All right, so you can have a go at that. So if you want to have a go at that, pause the video now. Otherwise, I'm going to go on and show you that as well. So let's have a look if you are working on with me. I'll clear my board. I will attach the rubber band here. This time I want 5, 1, 2, 3, 4, 5 by 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, now that is 5 by 5. Now what I need to know is if I can do two triangles here. So I'm going to see if I can change color. There we go. So I'm going to, no, it's not going to work for me. You know what, guys? I'm going to make a change here. I'm going to clear that board. I'm going to say that I want 11 in there. And I think I'm going to be more successful this time. So I'm going to go 1, 2, 3, 4, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. Then I'm going to put a new rubber band here. Let's change our color. Let's go nice and red. 1, 2, 3, 4, 5. And 5. And then I'm going to add another rubber band here. Let's change color again. And pull it down to here. All right. So I've got my square number and my two triangular numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 10 and 15, what do you notice? It makes 25. All right, let's go back here. And if you have a look there before I continue the PowerPoint, yes, indeed, it is 10 and 15 make 25. So yes, there were those two triangular numbers, and there they are there. All right, so we've proven that rule there. Now you can continue it and explore with the Geo Board and try other numbers to see if you can make square numbers from consecutive numbers. All right, and then when you're ready, restart the video and go on to the next section. Here's the next section now. All right, so this column here is about the size of the smaller triangle and the size of the larger triangle. And what we're saying is the smaller triangle added to the larger triangle should equal the square. So 1 plus 3 does equal 4, yes. 3 plus 6 does equal 9. The next two consecutive numbers, and as you can see I go from here to here. 3 was the larger one, now 3 is the smaller, and 6 is the larger. Now 6 is the smaller and 10 is the larger, and so on. So this number here drops down a line to this number. So 15 will end up here, and so on through. All right, you can use the Geo boards, or you can use just the patterning here involved, along with your other sheets where you recorded your triangular numbers, and see if the pattern continues. Pause the video and have a go now. Let's see how you went. There are the rest of the triangular numbers. Notice 15 drops down, 21, 28, 36, 45. And what we need to do is keep adding these together. And when we add these, will it make a square number? 2 2s are 4, 3 3s are 9, 4 4s are 16, 5 5s are 25. There it is. That adds to 36, 6 6s, 7 7s, 8 8, 9 9s, and 10s. So, yep, it proved it. So we have shown that every single square number is able to be found by adding together two consecutive triangular numbers. Maths is full of patterns, and that's the pattern between triangular numbers and square numbers. That's it for today, guys. Quite a long lesson there, but I hope that you enjoyed exploring the relationship between square and triangular numbers. Okay, cheers for now.